So hi everyone, thank you so much for coming. Today we'll start with Pandas. Last week we covered NumPy. So NumPy is, Pandas comes on top of NumPy. All right, and that is how you start data science. So if you need to do like machine learning, deep learning, usually start with Pandas. Maybe nowadays there is much more advanced packages than Pandas, but Pandas is a very involved package, and you could do everything with it. All right. The only limitation is gonna come, or maybe already come, the size of the table. So in here we're trying to deal with the tabular data. What does it mean, tabular data?
Structured data.
Alright.
And
Data that you could save in a table. Okay, that's basically. Okay, we have learned about containers. So if we started from containers, what the containers we have learned?
List tuples.
Okay, tuple, dictionary, right? What? String. Okay, array. Okay, in the array, for example. Okay, and today we're gonna talk about data frame. All right. All right, data frame. So basically, what is a data frame? It's like you're putting everything in a table, kind of. Okay, big table, huge table. Could be 1,000 columns, million rows. Could be huge, right? So basically, you have let's say like that. Okay. So what we call this column. You agree? And what you call this row, right? And as we have learned, everything has an index 0, 1, 2, to whatever n, for example. And in here we could have 0, 1, up to m, for example, right? All right. So what we call this, the whole thing, we call it what? Data frame. Right? And this one, if we take like a column, one column, what we call it? Series. So data frame is built off a bunch of series. So one vector, we call it a series. We call it a series, right? All right. So we could read the data from comma separated files, okay, or value, all right, or from tape separated value, or from a binary file, value per pickle, okay. So you could read, so you could read it, okay, and you could later on write it, save it to file, all right. The idea here that you have a data, you have a table, has millions of records, okay, or hundreds of millions of records or thousands of records that you're gonna manipulate, all right. So basically, down the future, when you have a data, let's say this data, for example, is related for a certain disease, all right. In machine learning or deep learning, we call them records, and we call these features, right? Features. We call it the features. And then this data, the first thing we do with it, we try to clean it. We try to normalize it, remove the empty or substitute for the empty files. Okay, do many things for it. Then after that, you pass it to your machine learning model that you have designed. So the pre-processing of the data is a very important part, right? And that's what we do with NumPy and different packages we're gonna learn. The other thing you do is graphing, plotting, right? Maybe you don't want to do machine learning or deep learning, data science, analytics. Before machine learning, you're gonna do analytics. You're gonna analyze it and have a plot and plot the data and manage the data. So it's a very important package, and this will be your bread and butter until the end of the semester. And the exam, you only have questions about pandas and data science. So formally, I'm telling you now, you are authorized to forget everything you have learned in the class, right? Right? Including NumPy. You'll never find a single question in your exam what NumPy. That's what we're gonna do. You see, we're gonna finish all of this and more, but you know, Panda is a very involving package. I mean, I was looking today in a book, like about 2,500 pages. Okay? So let's say that's your job. Let's say you finish from here, you go for a job, and that's your data. Your job is to data analytics, machine learning, deep learning with pandas. What do you have to do first? You have to become very expert. You have to know every single feature and function that it has. It might require you 6 months, 1 year to practice to do it, and all of that. Then you'll be very good in your job. And he will introduce you to it, and the introduction will be a little bit involved. All right. So seriously, make sure. I mean, it's a new start. You are reborn again today in this course, and that's what you have to do until the end of the semester. Pandas, data science, regression, linear regression, dealing with data, and all of that. Okay. So that will be your life. For those emailed me about their midterm, they did not do well. What did they say? I said your final will replace the midterm. So you could forget everything before, and you start from here. So this is a new start. It's a new start, and still you could do very well in the course. Okay, a lot of work you're gonna do, and then you have the project. You have the rest of the homework. Yes, sir.
So forget everything and just remember.
Yes. Don't forget everything. You could forget me too. If you can.
Oh, if I
Okay.
can.
Huh?
He said if I can.
If you can. Alright? Because you'll not be able to write a pandas code without knowing Python. Alright? So easy to be said. Okay, so you're gonna use the for, you're gonna use the if, you're gonna use all of that. But forget everything before start fresh. Still. Alright? Alright, any questions? Any questions? Alright? Okay, so that's what we'll be doing in the next few weeks. Right? We will focus our efforts on also what I told you, I mean you should have brought your laptops with you. Did you get my message?
Yeah.
Alright? So they have it. I already sent you the zip file, just all you have to expand it. Okay, let me go in here and see what they expanded. So so what's behind here?
Never you still work the night shift that day.
So if you go in here, that's the root folder. It's pandas for everyone. You could put it in your C drive. You could put it anywhere. You could put it in as long as you where it is. All right. Then you go to training. I think. Yeah. These are the IPython. This is the interactive Python. So all, you go in here. If you go top in here, you type CMD. All right. CMD. It will open a terminal and it will put you in the directory. It will be the same folder where you have things, right? And then from here, what you gonna Jupyter, I think, note, book, Jupyter, Jupyter notebook, and it should bring you to a web page. Okay, in here. So you see, this is the code for chapter 1 up to chapter 9. Alright, so if you go to intro, so basically that code you will find in the chapter. Alright, you could directly play with it in here, modify it, see what changes you could do. Alright, and you could also write your own code in here. If you don't, yes,
It says Jupyter is not recognized.
you have to download the package. I already put the instructions last week for you how to download
I
it.
did.
I'm able to see the files, but when I click on it, I don't get anything.
I cannot help you right now. I've been in the class, we should have seen before, but I put the instructions. There is a package called pip install IPython, and you should be able to use it. If there is a problem, then you have to see me after the class. Alright? Or just Google it, how to install it. Just Google how to install it. Alright. Okay, so you could play with it. If you don't, I mean, myself, I think this is good to try things on the fly. But the best thing is to have like you know, different IDE, like, you know, PyCharm, and write the code, add the packages, and play with it. All right. You know, the best thing always to type by yourself. Anyways, I already created also the PowerPoint presentations for you from this book also, so you could look at the IPython, you could look at the PowerPoint, you could look at the book, you could find another source for information for you. You don't have to follow what I do in here. You know, there's so many resources there. All right. That's what I will do myself. I will do like pick up like different resources and try to move from there. All right. So Pandas is an open source data analysis library. It gives Python the ability to work with a spreadsheet-like data, like tables. And you could load them, then you could do manipulation, you could alignment, you could merge different tables, I will see, you could normalize the data, you could create different data and new data derived from other data or different data on the table already, and many other functions. It's a very wide, very huge, you can do everything. Pandas introduces two types of data types. The first one is series, which just I explained, is kind of vector, and the other one is a data frame. The data frame represents your entire spreadsheet, or the rectangular data. Series is a single column of the data frame. So you have series data frame. So we'll work a lot of series and data frames. Of course. I mean, many times that you need to you have multi-dimensional array, and the array you're gonna convert it to a series or data frame. You could have a list, you convert it. You could have a dictionary, you convert it. So, I mean, when you work with Pandas, the first step is to bring your data to where? To data frame. Then you could do whatever you want. After you are done manipulating your data in the data frame, what you do? You push it back to a file, you save it in a file. Save it back to a file. It could be a comma separated file, it could be a tab separated file, it could be a binary file, it could be any of those. So of course, when you work with Panda, what is the first thing you have to do? You have to import it. You have to import Panda and typically what you do, import Pandas as PD. Okay, so it's a shortcut as a PD. Import Pandas as PD with a library loaded. We can use the read underscore CSV. So you have your data. I mean, there is a lot of data sets in the internet. Depends on the application you are looking for. So you could have thousands of data sets. All right, and usually they are like comma separated values or tab separated values. You have to bring them to your data frame to deal with them. So then you could do whatever you want to do. There is thousands of things that you could do with that, right? All right. Any questions so far?
Yeah.
Yes.
So in the first slide, it was that two more new data types, that is series and data frame.
Yes.
So the series data type is similar to that we used till now, or it is something different?
It's similar to a vector and NumPy. So again, the column in here is what's called series.
So the data that we have in the series will be of the same data type, or it can
A different
be of,
data type.
It can be of different.
It's a different
data
data type.
So
If you type type, it will be different data type. And it's called series.
okay. Because the last assignment that we worked on, if I was trying to insert data in a column, so it was giving an error, because if we have two different data types, then if I use string, then all the floats were also getting converted into string. if float was considered, then the string was not in there.
We are talking about two different things right now. Okay, so the data inside
Series.
the data frame. Okay, each column has to have the same data type. So it could be string. All right.
Yeah.
The series itself is an object, a different data type, which is series. All right. The whole rectangular shape in here is a completely different data type. What we call it?
Data frame.
Data frame. All right. And by the way, as we'll see in a second, we don't call it a string inside data frame. We call it object. We call it object, as we'll see. All right. So go back to your homework. In your homework, if you have a numpy, what is one condition we have with numpy? Everything has to be the same data type. So if you have array or in the array of integers and you try to insert a string, what will give you?
Right.
Error. Error. You have to change it if you can change it, right? So in here, in the data frame, each column has to have the same data type. So for example, let's say we have age, okay, and it's a float. So everything in the series has to be a float. All right. So very simple in here. As you see in here, the first thing we're gonna do, we create a data frame. Let's call it df pandas. Okay. Dot read underscore CVS, and you're reading the file wherever you store it. So you put the path for the file, and the file is gapminder.tape separated value, and because the default is comma separated value, what I have to tell the separator is a tab. All right. If it's a comma separated file, you don't have to worry about it. So now everything in that file, everything in that now it's a data frame. So for example, if I go in here and it's in data, for example, which one? Here, that's the one. If I try to open it, the file, and let me open it with what? Open it with Excel. anyways, so I open it with Excel in here. So you see the first column is country, and then you have the continent, you have the year, you have the life expectancy, population, I think, whatever, it's like, it has like 7 columns and many rows, right? So we bring all of this to our data frame. We bring it to the data, oh, can you see? We bring it to the data frame, all right? All right, and what's the name of the data frame now? It's DF. All right. So if we need to access the data from now on in our program, we access it through the DF, which is the data frame. Right. So if I say df.head, what will it print? Will it print the first 5 rows in the data frame? So in here you have like the columns names, country, whatever, continent, year, life expectancy, I think population and GDP per capita, okay? And then in here we'll have the index, the row index, all right? The row index does not mean the row number. Could be the same, but usually they are not the same, as we'll see. All right. So we load a simple delimiter. So if you need to know, if we saved everything in the data frame. So if I try to use the type function to know what type, it will mean it's what? A data frame. Remember, from now on we're gonna deal with series and we're gonna deal with data frame. All right. Also, there's attribute give you the shape. So the shape in here, it will give you a tuple. Will tell you the number of rows and the number of columns. So how many rows we have? 1704. And how many columns we have? 6. What are they? Country, content, year, up to the GDP per capita. Right? All right. So since shape is an attribute of the data frame and not a function or method of the data frame, it does not have parentheses. And this is, we know it already a lot from Python. So you could have methods, you could have functions, and you could have attributes. Okay, methods is part of the class, functions are general function, and attribute does not have the parentheses. Okay, it's kind of decorator, and we explain decorator in the advanced database, advanced Python class. All right. So in here, for example, if I you put the parentheses, what will give you? Error. It will give you an error. Okay, it will give you an error because it's an attribute. All right. If you would like, there is another attribute, columns. If you would like to know the name of the columns you have, okay, so df dot columns, and will give you the columns you have. Will give you the headers of the columns you have. All right. So far we learned how many attributes? 2, the shape and the columns. Okay. All right. So what we have in that table in here? We have columns. We have rows, and we have cells. Right? We have cells. So we need to have access either for a whole column, or for a whole row, or for a cell, or a bunch of columns, bunch of rows, bunch of cells, right? How you can have access to this data. All right. So we're gonna go over that in a few seconds. So subsetting columns. If we want only a specific column from our data, all right. So we can access the data using the square brackets. So as you see in here, okay. So df, and we use country. So this will go to the data frame. It will pick the column that has the country header, and will save it where? In another data frame. It will save it in another data frame. And we give it a name, country underscore data frame. So now, if I go print the head, the first 5 lines of this new data frame, give me only one column, which is the which is the country. All right. If I print, okay, the end of the data frame. So for the first lines, 5 lines by default, 5 lines, you use head. For the last 5 lines of the table, what you use tail. And the default is how many records? 5. If I need 10, for example, very easy. I say n equals 10. You could tell exactly how many lines you need. But by the default is 5. Usually you cannot display it as a whole because usually it's like thousands of lines. You'll not be able to see. You will not be able to see. All right. So looking at columns, rows, and cells. All right. So so easy. Now to subnet a column, how you can do that? Very simple. You go data frame. You go to the data frame, for example, you call it df, all right? And you subnet the title, so the head of the, for example, the country. Okay? And you could save it in data frame 1, for example. All right? All right? If I need to have 2 columns, for example, so data frame 2, df, all right? I could say country and whatever continent, for example, whatever we have, POP, for example. Okay, so it will print the data frame, only 2 columns, but all the rows. So looking at columns and rows. So submitting rows, so there is 2 functions to subnet rows. The first one is location, and the other one is iloc, index location. And they work differently. Let's take a look. So loc and iloc. So for the column, we did not need to have a function. For row, we need to have a function. So what you do in here, print, for example, loc 0. So what's 0 here?
First entry. First entry.
It's what?
The first entry.
The first entry. But what is 0 by itself? Is it the index or the row number?
That's the index. No, sorry,
Series
that'd be
number.
iloc.
Row number.
It's the index, huh?
It's the first one.
In the first line, but what is 0? Is the index. Okay, it's the index, not the row number. Okay, not the row number. Okay, although in our example in the data frame here that we are using, the index is similar to the row number. All right? I know it's not clear, let me explain it. So for example, take a look in here. So in here, these are the index, but they are equal to the row number. So 0 is an index, okay? 1 is an index. All of this is an index. But it's not necessarily that we have an index as number. So it could be, for example, a date. So for example, it could be, this could be, for example, January 1st. This is January 3rd. July, whatever, 4th. Okay? So the index could be number and could be something else. Alright? So if I have the index as a date, then the index does not equal the row number. It's not the same thing. Alright? So let's say now my index is a date, like this. So if I need to access the first row, how can I access it? So let me ask a question. If I say, for example, df dot loc 0, wrong or correct? In this scenario in here, to access the first one.
Wrong.
Wrong. Alright, it's wrong. This is the row number, if I need to do row number, I have to use I. If I need to use the index, I have to use the index. What is the index? df dot lock January 1st. That means I could access any row either by the row number, then I have to use the I location, or I could use the index, which I could create myself, okay, that index the table, and then I have to use my index. Okay? So again, to access a column, you don't have a function. You just access it like you access list before, right? To access a row, you have two functions, iLock or lock. Lock for location. Maybe more examples will make it
So
much more
string
clear.
slicing is not possible then if I am using a date.
What?
Slicing
It's possible. We're gonna come there. We're gonna do
using a
that.
date also.
We're gonna do no slicing in a second. Alright? So, so we already finished that? Okay. Alright, so in here, okay, in here, it's not the row number, it's the index. It just happened the index is equals to the row number. So index of a data frame in the Python starts from 0. So the first row of the data frame is returned as output. Alright. And here, for example, data frame print location 0 gave you that. Location 99, okay, location 99 gave you what? The location number 99. So to get the 100th row, Python counts from 0. All right. So if you need to know if you use the shape, what does it return for you?
The total complete
Okay,
rows and columns.
tuple, which has rows and
Columns.
columns. So tuple, yes.
Will that be unique to every row?
What?
The date will be unique to every row.
Not unique, no, different.
And
So-
I'm
so-
just saying of it,
It will be indexed by date. It could be indexed by country. It could be indexed by anything you want.
Means different countries for each row, right?
It could be. It has to have different. For example, let's say that you have, for example, they cannot repeat. It has to be unique. It has to be unique. Yeah, definitely. Yeah. Okay. So in here, when we did in here, okay, 99. Okay, is the index number. Okay, so get the 100th row. Python counts from 0. Okay. So usually, if you are using, for example, the shape will give you a tuple, right? Tuple has two elements. The first element, the row number, and the second one is the column number. So in here, what I'm trying to get in here, the first element of the tuple, which is the row number. I'm saving it where? The number of rows. Now I have in here integer variable which has the number of rows. Okay, what is the latest row index will be number of rows minus 1. Number of rows minus 1. Why? Because we start counting from 0. Alright now. Okay, now, so print data frame location for the last look or location for last row index, and that will give you the last row index. So you cannot use, for example, -1. You cannot use -1. For slicing, we could use -1. With iLock, you could use -1 as an example. Clear so far? So iLock does the same thing as lock, but it used to subset by the row index number. The row index number. In our current example, iLock and lock will behave exactly the same way, since the index labels are the row numbers. So we have index numbers and index labels. In here we call it index label. The numbers we call it a index number. Labels and numbers. In our scenario, in our database there, in our data frame, they are the same. All right. So in here, if I need, for example, if I say I look 1, so this will give me which row? 2. Will give me the second, right? Because you start from 0. So this is basically the second. And you printed the country is Afghanistan, the content is Asia, year is, life expectancy, pop is, you know, all of that. And the name, the data type is an object. In here, if I need to access the lost record, what should I do? I could use the -1 easily, because you know we are using in here index numbers, not index labels. Index numbers, not index labels. And we learned about the index numbers from before. -1 means the lost record, right? So in here will give me the lost record. So give me the lost record. All right. So looking at columns, rows, and cells, and here subsetting columns by range. All right. If you remember, like in Python 3, when you say range, what does it return? The range function, what does it return?
0 to
Yeah, but what type, what kind, what is the type?
list.
Is it what?
Integer.
Integer, but what is the object type?
Tuple.
Tuple? It's not tuple.
List.
So when I say, for example, range 5, right? But we know it returns 0, 1, 2, 3, 4. But what type? What is the type of this? Is it list?
Yeah, it's list.
Is it tuple?
List.
List, right? Unfortunately, it's not list.
It's
In
immutable.
Python 2, it used to return list. It returns generator. It returns a generator. You know what's generator? We explained it, right? It returns a generator. That's why in here, when I try to create a data frame from a generator, I have to convert it first to list. If you are using Python 2, you don't have to do, because the range will return a list. Here it does not. So in here, now I have a list. Small range is a list. Okay, when I print it, I have a list. All right? So if I would like, for example, to pick certain columns, as you see in here, subsetting. So in here, I location, there is comma. In here is the rows, and in here we'll have what? The columns. So when I have empty column, empty, that means all the rows. All the rows, right? When I have it empty. Comma, this will give me the columns. So small range will be substituted for what? 0, 1, 2, 3, and 4. And when I print the header, what I had supposedly all the rows, but how many columns I have? 0, 1, 2, 3, and 4, and the 5th is missing because I did not request it. All right. You got the point in here. So so what we learned before, let me put it again in here. If I'm trying to get a whole column, so df, and it could index it with the name of the column. We'll print all the rows with a certain columns. If I need just to print 2 columns, very simple. The first column, comma, the second column, close it. All right? So this is indexing by the column. If I need to get the row, what I have to do? df dot lock. Okay. And what do I have in here?
Index.
I have the index. Index what? Label. df dot I lock, what I will have in here,
The row number.
index number, which is the row number, index number. In some scenarios, we could have them equal, that's fine, not necessarily, right? So this will give me, okay. Now, if I need, for example, to get, now I need to get both. I need to get certain rows and certain columns only. So what I have to do? Slicing. I have to do slicing. All right. So to do that, okay, df, okay, I have to have first the rows and then the column. So if I say df, okay, a list 1, 2, comma, and a list 3, 4. So what does this mean? Give me the first and second row and print only third and fourth columns.
Are those zero based or one based?
Zero based. Zero based. Alright?
So it'd be the second and third row.
You're right. This will be second and the third, and this is fourth and fifth. You're right. Alright?
What if the row index is a date? Still this will work?
In here?
Yeah?
No.
Then every time I need
In
to
here,
know the exact
in
date.
here what we are using, the index number.
Yeah.
Slicing always index number, remember that.
Okay, so but if okay,
Index
I
number.
need to use that I thing.
Okay, index number. Slicing always index number, right? So in here in this example, okay, in this example, what they did, the I lock in here. So in here, what you're using the index number. So you have a start, end, and stop. When you have one column, it's a start and end. So starts from where? 0, and ends where? -1, the last one, right? So this means we'll print all the rows. In here, we have a list. What's a list? 0, 1, 2, 3, 4. That means we'll print how many columns? 5. Column 1, 0, 1, 2, 3, and 4.
What's the difference between using iLock and not using iLock?
Actually, to be honest with you, I think in here you must use iLock. So it should be def.ilock. Def.ilock. When you need to have access for columns and rows, you have to use iLock. Alright? So in here, for example, this example, again, I created a list with 3 elements, 0, 1, 2. I saved it in a small list. Then in here, the same thing, okay, I lock all the rows. Why I don't see all the rows?
The head,
Because
first
when I
5.
have the print. But if I print subset without head, it will print what? All rows. 1700 Alright? And then how many columns I will print?
3.
3. That's why I have country, continent, year. Continent, year, okay? I mean, you have the code in front of you, by the way, you could play with it, right? You have it in front, you have your laptop, you have it in front of you. Alright. So, subsetting multiple rows and columns. Alright, so that's what I said in here. Remember in here what I said? You could have rows and columns. So in here what I did in here, so def iLock, okay, so I need, how many rows I gonna print? 3, which is row 0, row
100.
100 and 1000. And how many columns? 3 columns, which are 0, 4, and 6. Right? And that's exactly, this is 0, 4, and 6, and that's it. Alright? Alright? So what we are learning, that we could subset by column, or multiple columns. We could subset by rows or multiple rows, two ways, and we could subset with columns and rows together. Clear? And it's very important to be able to use these tools, because remember that you'll be dealing with data with like 1,000 rows or 1,000 columns or 100 columns with thousands of lines of rows. So you cannot visualize it. You cannot visualize it, right? And you could do search for a certain value. Okay, so let's, for example, if we have, for example, life expectancy, okay, I'll be able to search for all the rows that has life expectancy for, let's say, greater than 40 or less than 28 or whatever. All right, so you could add conditions to it later, and you could like pinpoint certain values, and you know exactly what row they are in. Right? Okay. And this is very important later to clean up the data. So for example, not every data set you download for your project, for your research is clean. So you'll find some empty cells. You will see you'll see wrong data. Why you will have wrong data in one spot in your data set or multiple spots? Because this data entered by who?
Humans.
By human. Right? By human, right? Right? And if you have like, again, you're talking about millions of records, millions of data, and when you feed it to your machine learning, it will collapse. Why? Because it will come to a certain data that's supposed to be there. All right? So you have to clean your data first. So these are useful, it's like your tools. You know nowadays how surgery is happening or the future will happen? It's like a robot, right? Now when they do operation, they don't cut you open from here to here. Right? They open like a small cut. They put a camera with robot, and the doctor can see everything. Does not put his head inside to see. All right? So there is a camera, there is lights, there is everything, and that's your tool. That's his tool, the doctor's tool. This is your tools to clean up the data. All right? Clean data. Okay. Sometimes you need to do data normalization. Okay? What is data normalization? Means converting data from one shape or format to another shape or format. So for example, let's talk about diabetes. So people have 3 levels of diabetes, right? Not diabetic, pre-diabetic, and diabetic, right? So non-diabetic should be like less than 100, I'm not sure what's saying it, 100, whatever. If the person from 100 to 130, then he's a pre-diabetic. Above that is diabetic. So you have the sugar reading there, and a person 99, this person is 102, 105, 502, 5. I don't care about all these numbers. What I care about, diabetic or not, or diabetic, pre-diabetic. Okay, so I have to have 3 values. So I normalize the data that, for example, any person has a number from 130 and above, I'll give him 2. Any person between 100 and 130, I give him 1, for example. And anybody less than 100, give him 0. So normalize the data. So instead of having a wide range from like 50 to 500 number, I have 3 values. That's normalization. Okay, you're normalizing the data. So you don't expect to go for 1,000,000 records and normalize it by clicking, right? It's by writing a code. All right, so that's the pre-process for any data analysis, or you understand the whole point, right? So the first part of this course will teach you how to deal with all of that. You could write the functions and put rules, how to fix your data in your data set before you do all this work, right? So in here, for example, what you're trying to do in here. So in here, I'm trying to use lock now. So in lock, what I use, okay, in the rows, what I'll have in here. Index what? Number or label? Label. Index label. And then here what I have? The column labels. So with lock I use labels. With iLock I use index numbers. Index numbers and printed there. Alright, so the first thing you do with the data usually like statistical operations, right? And the statistical operation usually is in a group of data, not all the data, for example, right? So in here what do you do? So you group this, you group by, so that data frame, there is a function called group by year, alright? So there is all entries with a similar year, make them what? One group, multiple groups per years, right? And I care about what? Which column? The life expectancy, and then what I do? Get the average. So group by the year for the life expectancy, and then give me the average of life expectancy for that year. Simple. So as you see in here, how many years I have in all the data sets? 1, 2, 3, 4, 5, 6. All right, and this what for all the entries that have this year. This is what is the mean. Mean means average. Means the average. So you'll be able like to group, do different operations with your data. So group year. Okay, so in here, let's take them step by step. So what is the first line do? DF, group by year. So if I save it in a variable in here, I try to do a type. Okay, it told me what it is, a data frame group by. Okay, then in here when I try to print it, what does it give me? The memory location. The memory location does not give me the data. All right. Then in here, what we do? Group by continent. And I'm trying to see in that continent how many unique countries in my data set. So in here I have like continent, okay, Africa, Americas, Asia, Europe, Oceania, okay, these are the continents. Inside Africa, in my data set, I have 52 countries because I'm trying to see how many countries there. In Americas, 25, and so on and so forth. All right? So a lot of statistical operations that we could do after K. What time is it? Is it 1:00?
7:05.
7:02? Thank you. So in here, let's create a series. Okay, Pandas series is a one-dimensional container. So in here we have series, columns, and we have the whole data frame. So let's take a look at the series. Okay, so in the first part of the slides, what we have learned, how to load a file, comma-separated file, to where? To a data frame, and then try to read the data. Read the columns, read the rows. What if I need to create my data frame? From a list, for example. Okay, I need to create my own. So I could create a series, and I could create what? A data frame. All right, that's what we're going to talk about now. I'm creating my own. Not reading to a data frame, I'm creating my own. All right? So when you look in here, Pandas series is one-dimensional container similar to built-in Python list. It is the data type that represents each column of the data frame. Each column in the data frame must be of the data. So for example in here, okay, we import Pandas as PD. So PD, which is series, and what I'm creating now in here, a series, which means, okay, a series, and has two elements, Panda and 42. So if I print S, which is a series, so the 0, index 0, give me Panda, banana, I'm sorry, and 1, which is the 32. So with the series function, with the series method actually, I could create what? A series. I could create a series, right?
42 is a string or a
What?
42 there is a string or a
Well, by default, I think we'll take it as a string. Okay, and remember in here, string in Pandas, we don't call it string anymore, we
It's
call it
an object.
object. We call it object. Alright?
Then what is the need that we need to have same data type when we can enter anything?
Sure.
Because in the end it's an object.
So this is a series not inside a data frame. So it's like a row. Okay? I think also the row, it could be considered as a series. I'm not sure about this, but we'll find out. So in here, for example, this one maybe will make it clear how we assign an index, right? Remember, it's index label. So in here, for example, I'm using the series function to do what? To create a series, all right? What is the first element? Wes McKinney. The second one is a creator of Pandas, and I make index. That's the index. So now the index does not equal to what? To the index number. So in here I'm creating an index labels. So the first line will have person and the second one who. So when I print S, person and who, creator of Pandas. All right. So in here, if for this row, what is the index label? Person. What is the index label in here? Who. What is the index number in here? 0. What's the index number? 1. So I think now it's clear what's the difference between index label and index number. All right. So creating data frame. So again, how you create data frame? There is a function for it called data frame, and start with a capital D and capital frame. All right. And you know, the simplest way to think of data frame is like a dictionary. Dictionary of what? Of series. Okay, dictionary of series is kind of, right? So like, so in here, for example, name, so it's like, okay, this is a dictionary, right? It's a dictionary. So name, which is the index, and you have 2 elements. So what is name? Is a column called name. How many rows I have? 2. Then I have occupation. How many occupations I have? 2. Born. How many dates I have? 2. Dead or died. Okay, I have 2. All right. Age. I have 2. When I printed it, is like what? Age, born, died, name. Okay. So what is data frame? Is kind of dictionary of series. So that's the first series, the second series, third, first, second, third, fourth, and fifth. All right. How many rows I have in here? 2. So you could think of data frame as a dictionary of series. Dictionary, what does it have?
Keys and values.
Label and a value. What's the label in here? Name, occupation, born, died, age. What are the values? Long series. All right, long series. Okay, came from where? From a list. From a list. From a list. Okay, so okay. So in here, look at the scientist. Okay, and here I'm creating like a scientist. PD data frame. So you have data. Okay, what is the data? Okay, so the data is occupation. You have 2 names, born 2 names, died 2 names. Okay, age 2 names, and now I'm creating the indexes. So in here the index equals to what?
0.
To the number. Now in here I could use index equals the names. Okay, and the columns, that's the order. Give me the column, occupation, born, died, or that's the order. Now when I print scientist, look in here. Now in here, how many columns I have in here?
4.
4. In here, how many columns I have? 5. Okay, In here, what are the index labels?
Zero.
Numbers. What is the index numbers? Numbers too. In here I have 4 columns. This is not a column. What is this?
Index.
An index. That's why I don't have anything. Alright? So you have to be careful how you create your data frame because it will affect how you access your data later. Okay? Completely different data sets by the way now. This one does not equal this. Does not equal this. Alright. The other thing is what we learned about dictionary. When you create a dictionary,
You can add value.
it's not ordered. It's not ordered. So the order of the elements on in your dictionary will not be ordered because it's not ordered object. Or it's not ordered object. So that's why in here what I did, if I need to be ordered, I have to say the columns, okay, occupation, born, died, so that's how it appeared. Occupation, born, died, age. Why they are in the same order? Because I put the order in here. If you look at the previous one, okay, look, I started with a name. Where is the name? Came before the last. Then I had occupation. Where is the occupation? Came the last, but it's the second when I created it. Why? Because dictionary is not an ordered object. It's not an ordered object. If I really need to have the same order in my data frame, I have to use the columns in here. Or I have to use ordered, something we did not learn in this class yet, something called ordered dictionary. But for that you have to import a module and use ordered dictionary. But the normal dictionary is not ordered, okay? The order is not guaranteed because Python dictionaries are not ordered. If we wanna order dictionary, we need to use the order from the collections module. There's a collection use. So that's what you do. You have to import the collections from collections, import the ordered dictionaries. Okay. Then after that, yes, you know. You could data frame, so you have to call the order dictionary and you create it and will be ordered. Or much more simpler, why you need to import another dictionary library, just use the columns in here. We'll put the columns for you in order. Alright? Just you have to be careful about this. Alright? So in here, create our example data frame. So in here, data frame, again you have the data, which is the occupation, the born, the died, the age, the index, the columns, and when you print it, you know, select by row index. So in here, scientist dot lock, what you use? The index label. The index label. If you need to use by the index number, you use iLock and the number. Alright? So the very first, yes.
What is the difference between the label and the number? If you were able to use it for like the kind of similar kind of thing.
Yeah. So in here,
Compared to the other two machines.
well, in here, for example, in here, okay, in here, okay, in here, or in here, what you have in here,
That's the index.
index, no, this is the index label. Always in here, what you see in here is index label.
Okay.
But this index label is equal to the index number. What is the index number of this?
0.
0. What is the index number of this? 1. What is the index label of this? What you read. So index label, you have to see it in your eye. Okay? Index number is inherent, because 0, 1, 2, 3, 4, 5. Right? So in here, the index number equals to the index label. However, in our example in here, the index label is completely different than the index number.
Okay.
Index label, what you see in your eye. What is in here? Person who? What is the exit numbers? 0, 1. Alright? Alright, for lock, you have to use index what?
Label.
Label. For iLock, you have to use the index number. Simple. Simple. Okay. I hope I explained it well for you, but
Yeah.
you know, if you're still confused, good. Where am I? Okay, in here. So in here, print scientists will print, for example, okay, incubation work in order. Okay. All right. Slicing the data frame. So, for example, scientist.lock in here using the index label. Okay. If and I saved it to the first row. If I'm trying to see the type of the first row, it will give you what? A series. So each row is a series. Each column is a series. Print first law and printed like the series for you. All right. Series method usually. So for example, if I would like to ages mean. Okay. So ages. What is ages?
Data.
It's a series, right? So dot mean ages in here. I must have saved it from somewhere. So it will give you the mean, then the minimum, the maximum, the standard deviation. All right. These are the series methods that you could use. There are so many series methods, so you could apply any of these methods on any of the series if it's applicable. So you could, I mean, if it's an integer, for example, you could use minimum, maximum, mean, median, mode, quartile. Okay. And there is append, describe. What does describe give? Give you all the statistics. So I think in here, I'm not sure I didn't have it. Okay. So vectors of the same length. Okay. So remember what we learned about NumPy. What is the thing that you could always do? Broadcasting, right? So when you have vector equals to another vector or series equal to a series, you could do what? Broadcasting. You could do broadcasting, right? So in here, for example, print ages, time ages. What we did in here. You have the ages. I'm not sure where is the. So there is like a series called ages, and then it goes cell by cell and multiply them, put them together for you. Ages time 2, so we'll go to each cell in that vector or series and multiply it by 2. All right. In here, what you do when you have different sizes. So, for example, ages has how many elements? 7 or 8. And then you say PD series, you're creating your own series, and how many elements in this series you have? 2. So it will add the first element to the second, to the first one in ages. We'll add the first element to the second element in ages. So 38 plus 161. Those does not have values because you have only 2 elements. Will give you not a number. Will give you not a number. NaN means not a number, not a number in Python. So that's what happened exactly. So you see in here, this is what? A series called ages. How many elements it has? 8. It has ages, right? And then here what I have, I could use ages.sort index ascending false. So it will print it in reverse. It will print it in reverse. Reverse what? By the index. So started by 7, 6, 5, 4, 3, 2, 1, 0. 7, for example, 77 came first. 641, 641, and so on and so forth, and reverse. All right. So this will not, it just display it like that, but will not save it. It will not save it. You know, when you try, you go to reverse ages now and try to print it or try to multiply it. It will go to the same order. So for example, here ages times 2. So broadcast. So what the age in the 0? 37 times 2, 74, and so on and so forth. It will broadcast the multiplication to all the elements. Let's have a break and come back after the break.
processor.
I
I
did
don't-
it in one sector, civil engineering.
Every other
It's
Sunday.
It's good.
Yeah, I don't know South Indian.
So-
you know.
But it's
How
just
we
like
create the data
old
frames.
profession, so it's like it's very old concept.
So, so we could, as you said, that once you create the data frame, you could create logical operations on the data frame. So, for example, in here, scientists, you have to pick in here what? You have to pick the rows. So which row are you gonna pick? Where scientist age is greater than scientist age mean. So what is the first thing you're gonna calculate?
Me.
The mean. And then you're gonna compare the age with the mean. If it's a greater, print it. Alright? And print what? All the rows. All the rows. So you could do, not, I mean, you could pinpoint certain numbers from the data frame as you do. So the functions you could use with data frame, as we saw before, df, column name to single column, df, column 1, column 2, column n, whatever, so multiple columns. Then for the row selection, you could have lock, lock, and the row label, or you could have lock for multiple labels, so multiple labels, and then iLock for row number, or for multiple rows by the row numbers. IX and IX, this is like from Python 2, forget about it. And then you could have Boolean operations, so one row based on one pool, or multiple pool operations. Or you could have based on splicing notation, where you have start, stop, and step. Okay, start and stop. So you could have different axes. You could also make changes to your series or data frame. Right? So that's the whole point. You have a data loaded to your data frame. You're gonna do normalization. You could add more columns. You could add more rows. You could fix some of the data, change some of the data, all right? So, for example, in here, format the born column as a date time. So how is it entered? Like object. What object means in data frame? String. So any string, we call it object, right? So in here, for example, so born date time, okay? PDF to date time. I'm accessing the column which says born, scientist born, then I'm formatting it, year, month, day, right? And now I'm taking it, I'm saving it where in a different data frame. So that's the format. That's the format. Okay. You could also do the same thing with the died. So for example, scientist, the column is died, format, I'm formatting it and I'm saving it to a different data frame. So scientist and born, the column label is born date time, and scientist, and the column label died underscore DT. So in here what I'm doing, I'm adding two columns. So this column does not exist, and this column does not exist. So I'm adding two columns to the scientist data frame. And I'm giving a name or a title for that column. Okay, where I'm bringing them from two series, which I just created before. Born, date, time, and die, date, time. Where I created this in here. So this is the die, date, time, and this is what? The born, date, time. I created two series, and now I'm adding them where? To the data frame. Very simple operation. Very simple operation. Remember in Python we could have multiple assignments, right? So we have, remember that's, we don't see it in different languages, right? So I could, for example, okay, x comma y, okay, equals 1, 2. In Python I could do that, right? So the 1 goes to x and 2 goes to the y, right? So that's what I did there. Okay, series, whatever, what's the name of the scientist? So okay, scientist. Okay, what is this? Scientist? The data frame. Okay, now I'm putting a new column, title. Let's say X. Okay, all right. That's a new column. Then scientists, whatever. Okay, and I'm putting a new column. Okay, and call it Y. Then equal. So I have to have two values. I could give them from a tuple here. It should be tuple, by the way. It should be tuple, right? So value and a value. So the first value will go. This is a normal Python. That's a Python exploit. So, you know, now you could believe me, right? You could forget about Python, right? If you can. If you can, please forget about it, right? So, in here, whatever value gonna come in here, and whatever value gonna come here. So, what we did, we put the first series, this is a series 1 and series 2. And in the previous step, we calculated the series. So we calculated the series in here, and now we add them. So now let me print the scientists. How many columns we had in scientists before?
5.
We had 5, right? We have the name, born, died, age, occupation, right? Now we added how many columns? Born, date time, and died, date time. So now how many I have? 7 columns. 7 columns. Or 7 series. In one line. And one line was added. Alright? So in here, for example, okay, subtracting dates gives the number of days. So for example, look in here what I did. What you're gonna tell me what I'm doing in the first line in here. I'm adding a column. I'm adding a column, an 8th column. Okay, where is it coming? From subtracting 2 columns. The day the person died, the day the person born. It will give me how long he lived in days. And that's what if I print that, what I will have? A new column in here, which is how long he lived in days. By subtracting 2 dates. By subtracting 2 dates, the delta. Right? So now I have 8 columns. I have 8 series in this data frame. Very simply, you could add any column, very simply, by certain operation. You could operate in multiple columns, you come with a column. Okay? You could do normalization. Remember the example of normalization? You could write a function that you create like another series, alright? Or you could replace an existing series, like remember the diabetes number? You could make, instead of like number ranging from 500 to from 50 to 500, you make it like 3 numbers only, 0, 1, 2, for example, or 2 numbers. You could do all of that in very simple. Also, you could drop values. You could drop values or numbers. So look in here. Print scientist columns. What are the columns? How many columns we have now? 8. So originally we had name, born, died, age, occupation. Then we added born, date, time, died, date, time, and age, days, date, time, and then age, years, whatever. We converted the days in the years. You could have it, you know, this is 9, right? So I could, for example, scientist drop any column I want. If I look at the columns now, there is no age. It was dropped. It was dropped. Right?
What's that axis?
Hmm?
Axis?
Axis column. So age, axis 0 is the rows, axis 1 is the columns.
Oh. And if they don't match, there'll be an error.
Yeah.
Okay.
Alright, so now, you know, you did modification, that's back to your question, you did modification. What you did at the beginning, you loaded the data where? Of your data frame. You did all operations. If you need to keep the changes, you have to write them back where? To the same file or different file, right? Pickle, could be binary, could be so pickle is a binary file. Python has a way to pickle data. This is a Python way to serializing and saving data in a binary format. Reading pickle data is also backwards compatible. So basically in here, scientists name, print names in here, whatever in here you could, you know, two pickle names, which is like a smaller data frame I created. Names, two pickle, and you put the path where you want to save it. Just you have to give extension for that file as .pickle, .p I think, or .pk. Any of these will work. Okay, it will be a binary file. Binary file, you'll not be able to read it, right? You have to read it. The only way to read it is through Pandas. You have to load it to Pandas again to be able to read it, because it's like a binary file. So in here, for example, names, two pickle, and you save it in a pickle file. Okay?
Do we have an option to store it in some another file?
Sure. See, yeah, sure. We'll see in a second, right? So to read the pickle, okay, to read the pickle data is scientists, for example, in here. Okay, read pickle, and you give it the path for your file. You'll be able to read it. So you could save it to a pickle file binary, or you could read it, okay, and you could verify. So that's reading the file. Also, you could have comma separated values, and it's a very simple. It's like two CSV method. Two CSV. So load and two. Okay, so basically you have your file and use two underscore CVS and whatever file you want to save it in. And the extension has to be .csv. Alright? So you could load and you could save to CSV. Also, you could save it to Excel file. You could save your data to Excel file. Alright? The only thing that you have to import the library, which is import XLWT. Alright? And then you could use to Excel and you give the Excel extension. So you could save it to Excel file. There is two different libraries you could use. That's one of them. Okay, to save it to the Excel file. Data frame export methods. These all export methods. You see, you could export the data frame to so many formats. So you could export it to SQL. Okay, save it into SQL database. To sparse, to string, records, LaTeX. Anybody knows what LaTeX? Like editing tool for the LaTeX. To JSON. People work with the web to JSON. To HTML. To dictionary, to dense, to clipboard, it's all export. So there's so many functions. Okay, maybe nowadays mostly it goes to JSON. JSON you could use it, and SQL. SQL is very easy. All right. So without plotting is a very important package that you could use. Okay. In chapter 3, we'll talk about plotting. We'll take a few plots. I'll leave the rest for you to go over. But once you understand plotting, you have to understand the plots first. When there is a density plot or histogram, you have to understand the plots. And univariant, two-variant, multivariant. All right. So sometimes you plot, like histogram. Okay, it's univariant, one value. or two variables, right? These variables could be continuous and continuous, or it could be continuous and discrete, right? Sometimes you're gonna plot like 3 variables, right? So you have to understand, and all the tools are available for you, so for you to use. So data visualization is as much a part of data processing step as the data presentation step. So it's how you present the data by visualizing it. All right. Okay. So one very important library that you use it a lot is Seaborn. All right. The quintessential example of creating visualization of data is Ensemble's quartet. Anybody heard about this Ensemble's quartet? Okay, so this is talks about like a data set for the flowers, all right, and the flowers has like I forgot the 2 petals and forgot whatever the other type. So there is a ratio between the petals, or what is the other part? I forgot the flower. Anyways, like you know the span, the distance, all right, of the leaves of the flowers, right? So this quartet was created by this scholar, and they have like it has 4 data sets. Okay, for the numbers, but in the 4 data sets, if you calculate the mean for all of them, are the same. The standard the different numbers, but the mean is the same, the minimum the same, the maximum the same, the standard deviation the same. But they are completely different data sets. The way you could see and understand they are different when you plot them. You plot completely different, but the data as a statistical data is the same. And what he's trying to prove here, statistical data is not enough to give you understanding and representation of the data. Right? That's the whole idea. That's the whole idea. So this data set was created by English statistician Frank Anselmi, I think, Anselmi, to show the importance of statistical graphs. Anselmi data set contains 4 sets of data, each of which contains 2 continuous variables. Each set has the same mean, so 4 sets, completely different data, but when you run statistical values, you'll have the same mean, the same variance, the same correlation, and the same regression line. But they are completely different data. I'm not sure if you can see them in your book. I'm not sure if I have a picture from them in here. Here, these are the 4 data sets. So if you look at the numbers in each data sets, again, the same mean, the same variance, the same statistical values, but when you plot them, they are completely what? Different. So that shows you what? The importance of displaying the data graphically, because sometimes statistically they look the same, but they are not the same. They are not the same, right? All right. So these are the data sets, all right? So this is the data set. So X and Y. So like you know the X and the Y, the distance between one side to other side. So X and Y. So each data set has 11 values. So, 11 values. The second data set has 11 values. The third data set has 11 values or readings. The fourth data set has 11 values and data set. So if you take, for example, the mean from 0 to 10, and here take the mean, it will be the mean equal for all of them. All right? So, you know, he designed the data to look like, you know, but, you know, they are completely different data. All right? So the main package for plotting in Python in general is Matplotlib. Okay? So Matplotlib is Python's fundamental plotting library, and there is other libraries, plotting libraries built on top of it. Alright, so it's like the basic one. It is extremely flexible and gives the user full control over all elements of the plot. I'll show you now how it does it. Importing matplotlib's plotting features is a little different from our previous packages. So the way we do it in here, import matplotlib.pyplot as PLT. That's the standard way of calling it. Okay, that's the standard way of calling it, matplotlib.pyplot as PLT. So it has sub-packages, and the most important sub-package is pyplot, right? So look in here, first example, plot, okay? So if you look at the Ansomi, okay, Ansomi data set 1. So I'm taking the data set 1, okay, I'm creating a sub data set from the Ansomi data set 1 equals 1. So that means I'm taking how many elements in here? I'm taking it from 0 to
10.
10 only. I'm creating like a data frame from this, all right? And very simple. PLT for matplot.plot x and y. So in here, data set 1 x. What is x? This is the x's. And what y is the y's, okay? And I plot it in here, okay? So what is the first element? If we take a look, what is the first element in the set? 10 and 8.04. So if I look in here, where's the first one here? It starts from here, right? 10 and 8.4. This is the first one, then the second, third, and then they are connected by a line. If I don't want them to be connected by a line, very simple. Okay? Okay, I'll plot the x with the y, and then here I don't need it to connect, I need to present it by a circle. So they are presented by a circle. X and y, very simple. Alright. If I need to draw the 4 of them together in one canvas, so this is the figure. Figures can be created with multiple subplots. Okay? So this is for the 1, 2, 3, 4. Right? We could add the titles, we could add the axes for all of that. Okay? So, histogram, what is a histogram? Is univariate, okay? So you know what's a histogram, right? It's like bins. So that you have the data like this, and you could create bins, right? Let's say you're gonna have 5 bins. So first bin, second bin, third bin, fourth bin, fifth bin, right? Okay, so the data, you're gonna put them in the bins, right? Like distribution, right? So histogram are the most common means of looking at single variable. Okay, the values are binned. Okay, binned. They are grouped together and plotted with. So, for example, in here, the first thing you have to create a figure. So PLT figure, and I save it in a variable. So what is FIG is a figure. Okay, inside the figure, I could have axes. And you need to make sure that you see the difference between 2 words, very confusing word. So usually you have what we call this figure. Okay? Inside the figure you could have 1 or more axes. Okay, 1 more axis. So if you need to have 4 axes, okay, in here, this is 4 axes. So what we call this? Axis with E. Alright? Inside the axis what you have? Inside the axis what you have? Plot. A plot. The plot usually has two what? Or multiple what? Axis with I. Another axis with I. So you have a figure, you have to create a figure. Then you have to decide how many axes you have inside it with E. I'm not sure why they have to use the name axis, it's so confusing. Okay? Alright? And then inside each one you could have a plot. A plot. So if you go back to our plot in here, back in here, so how many figures we have in here? One figure. How many axes with E? 4. How many plots we have? 4. Each axis will have plot 4. And each plot, how many axes have? 2 axes. Okay? So how you do that? Very simple. What is the first thing you have to do? You have to create the figure. So PLT, you call the figure, you have the figure object, the bigger box. Then you create the axis. So you say axis 1, it will be added to the figure, and we call it subplot. Subplot, okay? So it will be what? Okay, subplot, it will be row 1. I'll go to row 1. Okay, column 1. So we're going to go to the first box. Okay, and it will have one plot. So in here, the axis 1, which already I created the figure, then I created the first axis with E. Now what I have to create? The plot. What is the plot? Histogram. So there's a function called hist. Now the hist has 2 elements inside it. What is the variable? Tips, total bill. Okay, there is a frame, data frame, and there is a column called data frame. And how many pins are you gonna have? 10 pins. All right, 10 pins. So I gotta look at the total bill and have 10 groups. Depends on how much the number, and put them inside it. Okay. And then I said axis 1, set title. What is this? The title of the axis 1. And that's what it is. So created 10 pins. Okay. So in this pin, okay, from whatever to 10, you have about 6. Okay. And here, which is from, let's say, 15 to 25 to 15 to whatever, 20. Okay, 10 in the middle, and here this is going to be what, 15 here in the middle. So in the 15 we have, about close to 70. So 70 transactions in this data set shows that people paid $15, around $15 tip. Okay?
Can one axis with an E have more than one plot
Can you have more than one plot?
or axis with an E?
No.
Then why do you have to define 1 for the number of plots in the previous slide? It was 1 position, row 1, column 1, and that third one is for the plot, right?
Yes.
If it has to have 1, why do you?
I don't think you could have multiple, as far as I know, but I'm not sure.
Okay.
I got your question.
That should be on the
Okay, so if you
figure
want
now,
axis
no?
with multiple.
Well,
Figure
well,
table
yeah,
like
but the
figure
Dolby set,
table
we'd have like a
type
legend to tell you which one it
Ah,
corresponded
yeah.
to.
So you. Okay, got it.
Turns that out.
जो आखिरी में है वो एक्सेस फर्स्ट ऐसा पता है
That's right.
According to this, the third one.
That's the sub.
Okay, what does it say in here? It's like, okay, so this is number of rows, okay, number of columns, and this is the plot number. So in here, the plot number does not have any value, okay, but in here it will make a difference. So in here, will be 2 times 2, and this is plot location 1, plot location 2, plot location 3, plot location 4. So the third number in here is the plot location. But in here anyways, I have one location, because 1 times 1 give me 1. Got it? Maybe next example I'll make it more clear. But in the subplot you can have one plot. So yes, one plot, but this is the location where it is in the grid. Okay, so scatter plot in here, for example, scatter plots are used when continuous variable is plotted. So for example, in here, what I'm creating a figure. This is scatter underscore plot. What is this?
Figure.
A figure object. All right. So in the figure object, what I have to create? Subplot axis. Yes, axis 1. Scatter plot, which is the figure. Dot add a subplot. Again, we have 1 by 1. Then I have one location, and then a scatter tips total bill, and then I have tip. So I want to see what is the relationship between total bill to the tip. Of course, when the total bill increases, the tip will increase, so it's expected to be like that, right? Okay? And then you have the title, the X label, Y label, see it like this. So in here, this is what we have in here, the total bill. So as you see, when the total bill increases, what will happen with the tip? Increases. And this is scatter plot. Let's take one more.
Professor,
Yes.
was the name of the x-axis frequency in the first figure, was it by default?
Which one?
Can you go to the first figure?
Here?
First one.
Okay.
How did that frequency name?
This is the title.
Was it
This
by-
is the title that I choose. So in here, what we call it. So in here, what I'm plotting. I'm plotting only the total bill. It's one variable, which is the total bill. So the total bills, let's say I have 70 bills, right? So I divide them in 10 bins, ranging, so 10 bins, okay? Let's say the first bin is ranging from $0 to $10, second one from $10 to $20, 30, 40, 80. So how many out of these bills fit in each bins? And I draw them.
How to decide the range?
From the minimum to the maximum and the number of bins. Right? So in here you decided the number of bins. How many bins you're gonna have? 10. So automatically it will look at the minimum and the maximum and divide them by 10 and give you the range. Alright, so in here for example box plot. This is a box plot. So what you do, again, plot figure. So box plot is a figure object. Then I'm creating what? A subplot 1 by 1 and location 1. And the axis 1 plot, what I have the tips, okay? Tips sex equals female. Then I'm looking at the tips for the female and the tips for the male. I'm giving the labels and then the labels. Then I'm printing it. So let's take a look at it. So that's what we do in here. So in here, this is like discrete. This axis is like discrete values, female and male. But this value, the tip is continuous value. So I'm drawing continuous versus discrete. And this is what we call this a box. So this, for example, has minimum, maximum, median, outliers. These the circles are called outliers. One of the statistical drawings. Okay. You could have multivariant. So for example, here multivariant, and here how many variables I have in this one. I have x, and I have Y, and they have the colors. Alright? So what is the X is the total bill. What is the tip? What is the Y is the tip. What are the colors representing a thing, male and female? So multivariate data 4, yes, if this is 4, maybe the size also of the circle. 4, the size of the circle. So it's multivariate. Colors will be okay, so you have like so the bill versus tip colored by sex and sized by the size. So in here you define, for example, to determine, like for example the record, okay, if sex equals female, they return 0, else return 1. So tips, creating an column here, sex color, tips, sex, apply. We're gonna talk about apply in next chapter. You could apply an application in a column. So apply, okay, and apply the function, and will give you either 0 or 1 for the values. Then you're creating the figure, you're saving the object, then the axis, alright, and it's a scatter, and you're gonna draw X, which is a total bill with the tips, tips, and you're gonna determine S for the size, so you multiply it by 10, the size of the table, how many people on the table. So the size of the circle, it will tell you, you know, how many people on the table, and the color will tell you the gender. The color will tell you the gender. Okay, we come to Seaborn. Seaborn is a library built on Matplotlib and provides a high-level interface with statistical graphics. It has a bunch of data sets that it could also import. So in here, for example, if you would like to load it, so import Seaborn as SNS, and you could load different data sets. Come with one of them is the tips data set called tips. All right, you can load it, and it will be saved in where? In tips. What is tips in here? A data frame. It's a data frame. All right. So again, Seaborn is a library. It's a graphical library. Comes with it with data sets, okay, that you could deal with. All right. And it has its own. I mean, Matplotlib could draw histograms. It has its own histograms. For example, in here. So what you do in here, plot, PLT, subplots. Okay. This will be the figure. So the output will be a tuple, the figure, and the subplot. So the subplots function is a shortcut for creating a separate figure object. In the previous one, what we did, remember what we did? We have to have 2 lines. The first line to create the figure. The second one to add a subplot to the figure. All right. This is a shortcut. So there is a subplot. We'll create the subplot, save it in AX, and we'll create the figure. We'll save it in histogram. So creates a separate figure object and adding individual subplot access to the figure. So let's try it. Okay. Okay. So in here, SNS, this a certain plot, tips. So that's the column we're gonna draw, and we're gonna save it in AX. AX set title, that's the title, and then you plot it to show it. It will be like this. So this will include the histogram and the density plot. If you would like to remove the density plot, all you have to add KDE false, and this will give you the histogram without the density plot. That is the plot. All right. Also, you could have the rug plot. So if you add rug true, it will give you the rug plot with it. So density plus histogram plus the rug plot. Okay. And this is in here, the counter plot. It's not histogram, counter plot. Okay, you could do that, counter plot. Okay. Again, you're gonna have PLT subplots will give you the subplot and the figure. Then you add the counter plot and the rest of the information to it. Scatterplot, the same thing. This is scatterplot. So until the end of the chapter, I will not continue going through these plots because I think it will be much more valuable when you try them by yourself. Okay. I'm sure all of you have the book, right? You got the book, right, from the library, right? All right. And also, I just send you the zip file where you have the codes, some of the codes that you could run plot. My advice for you, if you have extra time, which you don't, to try, to write the code by yourself, play with it. I did myself all this morning. Okay, I did it also last semester. I did semester before. Whenever I teach this course, I try to play with it because I forget. Okay, I forget. You don't know if you do not, so you have to learn it first, right? So it takes a while to pick up, and when you do things by yourself, you will do it. The homework I gave you, it has little one question about plot, simple plot, but believe me, I mean, if you're gonna work in data science, okay, if you wanna work for New York Times or anywhere, okay, nowadays, by the way, I mean, try this trick. Whenever you go to store, there is newspapers, right? Okay, pick any newspaper. This is a challenge. Okay, and just look at the first page. It's impossible that you can find any newspaper first page does not have graphs like this. Data science. Everything is about data science nowadays. All right. So that's what people do nowadays. Yes.
From a software development perspective, if you have a company that's building out an application, you have the option to pay for services like Tableau.
Tableau, yeah.
That will create, graphs and plots and things like that.
And Power BI from Microsoft.
How is the decision made to go with a third-party service versus building it yourself? Yeah.
Yes. Well, definitely, that's a good question. Yes. Usually, if you're gonna do just data analytics, you're gonna go with well-known packages. All right, such as Power BI from Microsoft and Tableau. All right, and they're very powerful, very powerful. All right. But the problem with these packages, they assume that you have filtered data, clean data, clear data. So myself, I worked, I attended a course in Dallas, I think summer before, and it was about data science. And in the class for 5 days, they taught us 2 packages, Tableau and Power. Even until now, I think it's installed in my cell phone because you could do it in. You could display the. Let me check. Let me see. Is it Power? I think it's Power. Power BI, right? See, it's still in my cell phone from that time.
What's the other one?
Tableau.
How's it spelled exactly?
Tableau.
Oh.
Yeah, okay. Of course, Tableau is much more powerful than Power BI, but these have like modules and packages ready for you to upload the data. So when we were working with that, if I remember correctly, the instructor gave us like data, and he asked us to fix it and normalize it using Excel. Then we have uploaded it to Tableau. Okay. And you know, usually, you know, when you work with the small data, it's possible to work with Excel and all of that. But definitely, this is much more powerful. That's number one. Number two is Pandas, and these packages are very strong and very good for machine learning and deep learning. So now that's the main thing, more than drawing graphs and all of that. All right. Number three is, so let's say that you are deriving your data from application that you are writing. Let's say that you are like doing image processing. So you have a lot of packages and we're generating a lot of data, and you need to draw these data and all of that. So you are using Python language for it. So to draw it is all you have to import a package, okay, and draw. You don't have to export it to a file. The file you then import it to one of these Tableau packages and all of that. So make long story short, yes, I mean when you go to these, like, you know, I call them third-party employees, you know, that they need to use the application without knowing how it works. Yeah, they will use Tableau and will use Power BI, right? And maybe others, I don't know about the others. But for us as engineers, and we are here engineers, scientists, you know, think about you're working with millions of records in genetics, for example, DNA and sequencing. And I truly don't know how much Tableau, what is the size of data it could handle also. All right, I really don't. All right, so yeah, I mean, like, you know, for simple data science or graphics, maybe, you know, Python is much more complex than you think. All right, but you know, for our work in machine learning, deep learning, Python is the first language nowadays. Is the first language. So you have to have your data. You upload your data to data frames, and from data frames you are calling the built-in sometimes deep learning and machine learning packages like CNN and support vector machines and many other packages you're gonna use. So it's kind of different of applications. But what I try to say with the data science now, data science everywhere. I mean, like every report you will have charts, histograms, you know, scatter plots. You'll have them everywhere. Every report they will have data chart. You cannot, you know, even like think about like your research work on paper, right? You have data, so usually you try to compare the data, your own data, with the previous work. Yeah, right? Or you compare different works in your work and your paper, like different experiments. So you have to be able to draw it. So it could be very useful. And there's another language called R. Okay, R is just only for data science. Right? And here it's much more powerful because you could do magic with your data. You could analyze it. You could, you know, change it. You could normalize it. You could do so many things, and then you could, you know, do whatever machine learning, deep learning with it, and all of that. Any other question? So as you see in here, I mean, this is plotting. So you know, just go through the other plots and try to take, you know, see what. Okay. Next week we're gonna talk, hopefully. So we'll continue. So next week we'll get to data assembly. All right. Chapter 4 will talk about data assembly. All right. Okay. So how to load data, subsetting data, and functions and class methods. Okay, data assembly. Then after that, we're gonna talk about something very important when you analyze data, which is missing data. What are you gonna do with the missing data? All right. So you have to fill up something. You have to do something. So you're gonna deal with that. And of course, you're not going to do it. You're not gonna do it manually, right? So there is functions to help you to check for missing data. And okay. Then we're gonna talk about something called TEDI data. TEDI data. How to make your data TEDI. All right. All right. So this is, you know. All right. Take the data. So what is it? The data. What are the characteristics will make your data? It's kind of normalization in databases. Everybody took a database course, right? So what do you do with the data first? Normalize, right? And like database, okay, especially a relational database. All right. And after that, we're gonna talk about data types. There are different data types. You could create your own data types, strings of data, then the apply. We saw apply. You could create a function and you call it for each cell or each column in your data to modify it. And then we'll go delve more in a group by operations, split, apply, and combine. Split, apply, combine. And then we'll work a little bit with data time, data types, data time, data types, and like we did it also today, simple thing, we did like, calculations with it and all of that. And then after that, I'm trying to excite you, you look bored. All right, so.
Machine learning.
Yeah, so we'll see. Okay, then just a second. Give me a second. I hope I'm exciting you, not boring you. But that's fine. Okay, then we talk about data or data modeling. So there is linear models. Okay, there's also centralized linear models, model diagnostics, and then we go with regularization and clustering. So these are like you mentioned, machine learning, early machine learning, and all of them we're gonna use what Python and Pandas and different packages. We talk about k-means, and we talk about very exciting stuff, historical clustering, how to cluster data, and all of that. So it's just introduction to machine learning, all right, and more. All right. Unfortunately, I don't know, we waste a lot of time covering Python in this course. All right. So we spent half of the class going over Python. People who know Python, how many people knew Python before they come to this class? Wondering. You knew it very well? Very well? One Python, okay? So, and then, because many of the students are from different disciplines, from mechanical engineering, electrical engineering, from business somewhere there, from business, so we had to cover Python and all of that. So my plan for next semester, in case you have to repeat the class, just kidding, okay, my plan for next semester, I'm gonna have 2 full days, 8 hours of class in a weekend, in the first week to cover the first portion. Okay, and then I tell the students it's a data science, so we're gonna go delve deep in machine learning more and more, starting from next semester. All right. So I think you'll learn enough. You'll be very good in programming. As I told you before, the most programming is a programming. It doesn't matter whether Python, C, C++, C#. Maybe you notice even in the assignments you have, if you are a strong programmer, if you have the concepts, syntax is not a problem. Even in the exam, right, and the midterm, syntax is not the major thing, it's the concept. If you understand, when you read the for loop, the if statement, the while statement, the function, the object-oriented programming, if you understand the concept, the language itself is not important. It's very easy. So I hope that you'll work on yourself. So for those who did not do well in the first exam, and I told you, I focus on the concepts. Seriously, and I needed you. I know the exam was tough, by the way. So if you did not do well, I completely understand, and you don't have to worry about it. The final and the second exam will not be that tough. It will be much more easier than the first one. But I really wanted you to test yourself, how strong you are in concepts. All right. So if you did not score very well, you know that you have some work during the summer, maybe to work a little bit in the programming concepts. All right. And if you did very well, don't be very happy. All right. It was a multiple choice, so actually be happy. All right. That's all. So I focus in the concepts in here. So please work in your concepts. Alright, try to work more on your concepts. And we'll move on, we'll give you introduction, and if we finish this book early, we have a couple of lectures more. I have another book, that have more material that you can go. Don't worry about the exam, so once we finish this, we'll give you the exam. What we cover after that is for your own. So, it's not like, I will not try to make it complex for you. So, whatever we cover in here, I'll give you a simple exam, just make sure that you interact. And then after that, if you continue on more materials, this will be add-on value for you that you could use it, hopefully with the following classes. Are you good? Are we still friends? Well, thank you so much. Yes.
Any update on there being a project for this one?
The project. All right. The project in this, I did not design the project yet. So before last classes, I was giving like massive project about designing like the canvas. That involves database, like GUI, programming, and all of that. I'm not doing that anymore. I need to make you work in data science. Okay, so most likely I will pick a few data sets, and I will ask you, to have massive analysis and graphing for data sets, which entail you to use Pandas functions, data normalization, fixing the data, and all of that. All right. So I'm not sure how complex I'm gonna do. Maybe I'll pick a data set and play with it myself, like corrupt it a little bit, and make you fix it. I didn't know. I did not decide. But hopefully in 2 weeks. It's too early. I mean, there is homework so that you're gonna work on. So work on the homework, and I will give you a project that needs only 2 weeks to work on. So even if you have it in the last 2 weeks, you'll be okay to do it. All right. Thank you so much. Good night.
Thank you.